Good morning students, welcome to our new online video class of chemistry. Today we are going to start our new chapter, the solid state. Unit 1, the solid state.
In your previous class, you have learnt about three major states of matter. What are they? Gas, liquid and solid. Among these, liquid and gases are called fluids because of their ability to flow, but solid cannot flow. The reason for that, particles in solid are not free to move in available space. This property you have already learned in your previous class. Now let's study some other major characteristics of solids. The characteristic properties of solids are they have definite mass, volume and shape. Intermolecular distance are short. Intermolecular forces are strong. They are constituent particles such as atom, molecules or ions have fixed position and can only oscillate about their mean position. They are incompressible and rigid. Why the solids are rigid? Because the constituent particles in solid have fixed position and can only oscillate about their mean position. On the basis of nature of order present in the arrangement of their constituent particles, solids can be classified as crystalline and amorphous. The major classification of solids are crystalline and amorphous. Then what is crystalline solids? If the arrangement of constituent particles is same throughout the solid, then it is called crystalline solid. If the arrangement of particle does not follow any regular pattern throughout the solid, it is amorphous solid. The pictures shows the arrangement of constituent particles in quartz and quartz glass. In quartz, you can see the particles are arranged in a ordered manner. It is crystalline solid. And in the case of quartz glass, the particles are arranged in irregular manner. It is amorphous solid. Next is characteristics of crystalline solid. It consists of large number of small crystal having a definite geometrical shape. Long range order, that is because a fixed pattern of constituent particle repeat itself periodically over the entire range. They have sharp melting point and they are anisotropic in nature because their physical properties are different in different direction. Physical properties include electrical resistance, refractive index, etc. Observe the picture. The picture shows the anisotropic behavior of crystal, and the picture represents the two-dimensional arrangement of two different kinds of atoms. If we measure the properties along the direction indicated by the slanting line CD, they will be different from those measured in direction indicated by the vertical line AB. This is because in the first case, if you observe, you can see each row is made up of alternate atoms, and in the second case, it is made up of same kind of atom. Next is characteristics of amorphous solids. The arrangement of constituent particles is irregular throughout the solid in the case of amorphous solids. It shows short range order and its melting point is not sharp. They are isotropic in nature because its physical properties are
same in all directions, and the physical properties includes electrical conductivity, refractive index, etc. Behaves like supercooled liquid. Examples for amorphous solids are cotton candy, rubber used in making hot water bags, and the glass used in making glassware. Classification of crystalline solids. Crystalline solids are classified into 4 types based on the nature of interaction between the constituent particles. The 4 crystalline solids are ionic solid, covalent solid, molecular solid, and metallic solid. The covalent solids are again classified as 2-dimensional and 3-dimensional, and the molecular solids are classified into 3: polar, non-polar, and hydrogen bonding. Crystals are composed of alternating positive and negative ions. Metallic crystals consist of metal cations surrounded by a sea of mobile valence electrons. Molecular solids are held together by weak intermolecular force of attraction. Covalent crystals are composed of atoms which are covalently bonded to one another. This table includes different properties of crystalline solids and their examples. First is molecular solids. Molecular solids are classified as non-polar, polar, and hydrogen bonded. In the case of non-polar solids, the molecule is the constituent particle and the attractive force is dispersion or London force. Examples for non-polar solids are argon, carbon tetrachloride, hydrogen, iodine, and carbon dioxide. And it is very soft insulators and its melting point is very low. In the case of polar solids, the constituent particles are molecules and the attractive force is dipole-dipole interactions. Examples are HCl and SO2. It is very soft insulators and its melting point is low. In the case of hydrogen bonded, the constituent particles are molecules and the attractive force is hydrogen bonding. Example H2O in solid state, and its physical nature is it is hard and it is insulators and melting point is low. Next is ionic solids. In ionic solids, the constituent particles are ions and it is held together by Coulombic or electrostatic force. Examples for ionic solids are sodium chloride, magnesium oxide, zinc sulfide, and calcium fluoride. It is hard but brittle. It is insulators in solid state but conductors in molten state and in aqueous solutions. Next is metallic solids. The constituent particles present in it is positive ions in a sea of delocalized electrons. And the attractive force is metallic bonding. Examples for metallic solids are iron, copper, silver, and magnesium. And it is hard but malleable and ductile. And its electrical conductivity is it is conductors in solid state as well as in molten state. Its melting point is fairly high. And the last one is covalent or network solids. And the constituent particle present in it is atoms. Next one is covalent or network solids. The constituent particles present in it is atoms. And the bonding or attractive force present in it is covalent bonding. Examples are
quartz, diamond and graphite. It is soft. In some cases, it acts as conductors. For example, graphite. Next, we are going to studying about different arrangement of particles in crystal. The crystalline solids form crystal lattice. Then, what is meant by a crystal lattice? Crystal lattice is the well-ordered arrangement of atoms or ions in the three-dimensional space. Let us consider a cube. We know that cube contains 8 corners. Suppose we are going to keep a particle in each of those 8 corners. We get a regular arrangement of particles in three-dimensional structure of every corner. This is one arrangement in three-dimensional. From this we can say what is a crystal lattice. Crystal lattice is the regular arrangement of particles in three-dimensional structure. If we replace the particles R by points, then the structure, crystalline structure, would be array of these points. And this is done by connecting the points in a regular network of lines. Let's look how we can construct a crystal lattice using this point. This is the lattice we have drawn. From this we can say if the particles are replaced by points, the crystal structure would be an array of points which is called lattice. And these points are called lattice point. And the space between them are called space lattice. If we connecting the points by regular interval of lines, we get lattice. Then the lattice points can be broken up into number of unit cell. What is unit cell? We can understand it easily by taking an example of Rubik's cube. How it is made up of? Rubik's cube is made up of by joining small units of cube. Consider the single cube as unit cell. From this we can say what is a unit cell. A unit cell is the building block of crystal lattice. I hope now you understood what we learned today. We learned today about characteristics of solid and different classification of solids, and different classification of crystalline solids, and also we learnt about crystal lattice.